Welcome to the pre-recording of lecture 43 in this 8-week course. It is the next to last lecture in the last session where we meet before the final exam. So the final exam happens at the end of the 8-week. So I will start by saying about the general policies and protocol of the final exam. And then I have prepared some sample questions. This first part in our last session focuses on computer literacy. The second part will focus on Python programming. Okay, so the exam will take place on Friday, 4 August from 10 a.m. till noon. This course has been in general online with pre-recording and recordings of the lecture, so it was perfectly fine if you took this course asynchronously. But the single event that happens where everybody has to participate at the same time is the final exam. So if there is something that prevents you from participation at that time, then please, I would like to know. The final exam is comprehensive, covers what we have seen. If you want to focus, so it's very good that you look, if you could look, so the exam is open book, but we have covered quite an extensive collection of notebooks and scripts and slides. So if you want to focus at least on this review. Look at the answers for the midterm exam. Even if you did the midterm exam, look at the other version. The final exam will also come in multiple versions. Look at the quizzes as well. If you have done something wrong on the quiz, make sure that you understand what went wrong and how you should have answered this. So this part focuses on computer literacy. There will be some code here, but in general, please make sure that you know when an explanation is requested, when a computation is requested, or when code is requested. That is essential. Please understand the questions. The questions will be emailed to you. There is no need to log in to the Zoom session, to our Zoom room. The questions will be emailed to you in a PDF file, which might be convenient for just giving an overview. But the questions are also emailed to you in a Jupyter notebook. And it would be very good if you could use that Jupyter notebook to formulate your answers. In general, you can answer any questions in any order, but it would be really good if you started from scratch with a Jupyter notebook, that you would at least indicate what the questions are. I will give an example of such a notebook. So I have two notebook prepared, one with the questions, one with the answers. So in preparation for this final exam, it would be very good if you would just look at the questions, try to solve them, and then look at the answers rather than going immediately for the answers. Okay. Um, Define the term, give an example, explain the difference. This is an open book exam. I do not want to read Wikipedia's copies. So Wikipedia is a resource, but if you are using a search engine all the time and copying and pasting from there, I will notice and you will give very few credits. So I want to see that within the context of this lecture, within the context of this course, you can explain it, you have understood the material. So that is important. Um, so then there is the aspects of what I would call the mathematical aspects. So in particular, the number representations. Everything in computer science is binary, and we group things in either groups of 8 or 16 or 32 or sometimes 64. So there are these binary representations, there are the logical expressions, the truth tables. So this forms the first part of this review. So more the mathematical aspects of computer science. And then there is the design. So we have seen algorithms, modules, objects, and classes. So there are three examples of this. Python is a framework language, and that relieves you from a lot of programming, but you have to know, nevertheless, the key algorithms. So when I may give you, as on this review here, I may give you a piece of code and ask you to draw the flowchart for it. Or I may, so that would then, for you to show, that would be then for you demonstrate that you can understand how a piece of Python code really works. So if you can draw things. In the principles of good modular design, I'm not going to ask a lot of code on the exam, but I will give you two different exams, which two different exams as well, but two different designs, and ask you to explain which one is best using the principles we have covered in class. So that is important. The same for the UML diagrams. UML is kind of extensive. We covered class diagrams and use diagrams. You must know when to use which. All right. There is a posted script literacy or literacy on terms. I once went systematically through every lecture and combed the terms. So you can run this. I may run this as well before making up the final exam questions. There is a hint to the lecture number. I could actually ask you which lecture did we cover this. Um, the internet is a wonderful resource, but you must also have demonstrated that you have taken this course. So that is important. That could be also one important task in getting prepared for the final exam. Here are some of the questions. So what is beta testing? What is white box testing? What is black box testing? So we did all the covers. So is beta testing, is it white box or black box, or is it both? So in many cases, there is not really a yes or a no answer to this, but it's mainly the justification in your own words. Um, Give examples of code of applications that we have seen in class. Licensing is important. What is GPL? What is the difference with public domain? Give examples. We have spent some time on complexity classes. There will be also a cost question in this review. We have addressed issues of multiprocessing, multi-threading. What is the difference between the two? That could also be a good question. Illustrate. What are the consequences for a programmer? How would you do this with Python? Have we seen an example of this in Python? Many more. Okay, so let's then go into the mathematical concepts. So everything in a computer is binary. There are simple Python commands to convert a number into binary notation, into hexadecimal notation. You can also go back, but it's important here that you demonstrate that you can execute all the computational steps, in the sense that I want you, when you answer these questions, I don't want you to write in words how to do it or give the algorithm or show what is the answer. That's all good and well, but you will not get much credit for it. So I will show how this these two problems must be solved. Logic expressions are important in their own right, but as programmers, we are concerned with the logic of our branching, of our if-else statements. When do we break out of a loop or not? And there may be many states, even if the logic expressions are small, a break statement in the loop can be anywhere. So reasoning about logic expressions happens with truth tables, where we are examining all possible true or false values. So it's important that if you have two variables, you have four rows. If you have three variables, you have three rows. So read the question first. So don't start with making a table of eight rows if there are only two variables. Don't limit yourself to four rows if there are three variables in there. So that's um, an important um, distinction again. On an exam, I want you to demonstrate that you can do this systematically. So in a complicated expression, you have the inputs. These are already two or three columns, two or three variables, and then all these sub parts of the expression. So the operands. I will give an example of that. Okay, understanding the question. So here is an application. So this is a review question. I spent quite some time doing both truth tables. I will, on an actual exam, only ask one of them. If you can do one or the other, then you can do this. Here, I expect you to be able to understand the diagrams that represent the logic gates that correspond to these operations. This is an extra question here, draw a realization of the second expression. So we did not practice this. The diagram actually does not, in the JupyterLab notebook, does not support logic gates, doesn't have these symbols, so you could make them, but let's not do this. So it will be sufficient that you can write the truth tables. I may give you a circuit. So here on this circuit, you see three inputs. You see 5 gates. You have to know the distinction between an AND and an OR gate. You have to be able to write the logical expression that corresponds with the circuit. And also evaluate them. So typically what does this circuit compute for these particular inputs? It's equivalent to first writing down the logical expression and then evaluating this. What does the circuit compute? It's 0 or 1. You can write a 0 and 1 if you're confident, but if it is entirely wrong, then you will have no credit at all on this question. And there will not be all that many questions on the final exam, so please take your time. Also, take your time to write your reasoning, to show your work. Again, if I see only final answers and if I see only neat polished code and polished text, I'm going to suspect some copy and pasting. So if it's correct, then you may get credit, full credit even, but if something is wrong, I will not be that lenient with given partial credit. All right, algorithm design. So here, the importance of this part is that you can reason on code. So there is a for loop in there so it is pseudo code. Although you could very quickly translate it into actual working Python code. I was using part of the notation of Python. But it is important that you can see what this code is doing, and also that you can reason on what is the cost of this algorithm. How many operations does it do? So the point here is that when we think about algorithms, we can visualize the algorithms with flowcharts. So you have to have done at least, preferably one flowchart. So there is the diagram in a notebook. Eventually, but that's not recommended, you could draw on a sheet of paper and use your cell phone camera to make a clear picture of this, and that somehow upload into Gradescope. But I don't think that this is faster, this protocol, than using the diagram. So in this course, we have systematically used the Jupyter Notebook, the Jupyter Lab environment that comes with this diagram. If you haven't installed it via Conda, it's not too late. It will help you. Design. There's a lot of reading that needs to be done here. And if you see a lot of reading, please be mindful that what is here requested is actually to answer the bottom line here. You had a very similar quiz, and several of you answered with just giving code. Just code. That is a flat out zero. So here you have a design. I will go through that question later, but it's actually here mainly important that you can refer to the key principles of modular design. So design is an important topic of computer science. If your design is wrong, it doesn't matter how good of a coder or you really are. If the design is wrong, then your program will also be inherently bad. Many programs get tossed away because their design is flawed. So that's why this is important. You must know the principles: information hiding, high cohesion, low coupling, design for change. So these are the three key principles that we have seen. Uh, if you miss the first question, one or two, you could still get a lot of credit, more than half of the credit on this question, if you can apply the principles with some phrases each for the uh, designs to justify your answer. Object-oriented design. So we are looking here at a car rental company. Use UML. UML is also supported in the diagram in the Jupyter Lab. So you must understand the difference between a class diagram and a use case diagram. So there will be two versions of the final exam. In one version, I will ask for the class, and another for the use case diagram. Drawing diagrams is important. So you also have to be able to justify your drawing. So for every item in your drawing, I will illustrate how you should solve a question like this. Here you should also justify this. And again, this is a question, so it is in the first part of this review. It is a question on literacy. We are asking for explanations, we are asking for reasonings, we are asking for drawings, not code. If you give here a class somewhere gotten from somehow, then you will get 0 credits. The same reasoning applies for the previous question. Okay, I have now two Jupyter notebooks prepared. I spend a lot of time explaining the questions. So you get questions wrong when you do not understand questions. I looked at some of your quizzes, and indeed some of the quizzes got a flat out 0 despite being open book plenty of time. If you do not get the question right, then um, it it goes wrong. So the questions that you will be given will be in a PDF file, like in the slides, or also in a Jupyter notebook. This Jupyter notebook will be posted at the course website. For the review, I made section headings. So these are 6 possible questions. So the section headings correspond to the topic. So 6 questions, 3 on design, 3 on mathematical concepts. In the final exam, you will have section headings question 1, question 2, question 3, etc. All right, these are the questions. They are review questions. So there will be 2 versions on the exam. One version will get the binary notation, the other version will be the hexadecimal notation. Through tables, you will have to be doing one of the 2 expressions. Observe here that these expressions are both in 3 variables, a, b, c. Sometimes we use x, y, z as well, lower or uppercase. Here you see the diagram. So the diagram is embedded into the Jupyter notebook. So you may also get an attachment which is a portable graphics. So you have to save this as well to see it. Or here now it could be useful to also look into the PDF file. As far as the algorithmic design goes, so here I give the statement to display an image. So unfortunately, you cannot use a diagram directly into a Jupyter notebook. But you can take a screenshot and include it. This might be also useful for me. If you take pictures, if you take screenshots, it's very nice if everything is in one Jupyter notebook. There is the algorithm design, and then the modular design, and then the object-oriented design. So reasoning about programs is actually very important in this course. Okay, I have now prepared a Jupyter notebook with the answers. I'm kind of halfway in this review. In some sense, if you are watching this prepare for the final exam, it would be good to stop the tape now and download the questions and start solving them and then comparing with the solutions. I'm going to scroll through this. I must say that I spent quite some time preparing the answers. So this is a review. So there are again 2 parts in this. So I could eventually also ask the opposite way. So given a number in binary representation, what is the numerical value in decimals? The same for the hexadecimal. But this is the first question. I don't want you to get worried. The main point here is that there is the shortcut. So, and actually it fits entirely on the screen here. The shortcut is in execution cell 10. And you're recommended to actually do this, but you must show your work. Just saying what the answer is, that's important as well. Jupyter Notebook has markdown cells and code cells. Always, certainly if code is represented, verify it, but also always if an explanation is required, even if this is a computational exercise, summarize. So summarize, because in this algorithm here, the bits come out in the wrong order. So you compute the least significant bit first. So I need to see here that the least significant bit, the first bit, so this is an even number, the least significant bit, the first bit that was computed, comes last. And we do the repeated division by 2. That's the algorithm. We continue till the number that we are having, the quotient. So the div mod is very important here, very useful, whether the quotient is 0. All right. You should be capable to also write draw the flowchart of this. I mean, but in the lectures we have seen the flowchart. The hexadecimal question is shorter, and you may actually a little bit nervous about this, but I may give longer numbers then. Also, the hexadecimal notation is a little bit more complicated because you have this A, B, C, D, E for the decimals 10, 11, 12, 13, 14, and 15. Um, the same point here. So you cannot just list the remainders. So 10 is not a good remainder here. It has to be abbreviated or written as the A. Again, please check this with the hex command. Hex will give you some advantage, but this will be the first question on the final exam, and please have this right. So this is important. Don't skip this question just by answering this in a very casual way. This first question, it counts for a lot. If you do this correctly, you will almost guarantee to pass because it gives you a lot of credit. All right, the truth tables now. So here you see the result. Result is neatly formatted. I must be So in solving this question, I first started actually with the second expression because it was shorter. Even I was a little bit intimidated by that first expression. But here is also a strategy to systematically solve this. And it's important that when you solve this question, I need to see that you have done this before so that you can actually systematically uh, format the output. So there are three variables. The first three columns contain all the values of all possible combinations. It's not wrong to write true for one and false for zero, but it will cause you a lot of typing. You should also do the operands, so the not A, not B, not C, they are requested. So, and here you see how this is solved systematically. There are four ORs in there. There are four parts in this expression. So I abbreviate them with E1, E2, E3. E is then the final column. And here it's important Markdown. Markdown, as the name suggests, is a very quick way to format tables. You can also do this in ASCII format. So you have the triple right quotes before and after. But make sure that it is formatted neatly. So don't really use a code cell for this, although you could as one long documentation string. But it is important here that at least you have practiced this once or you have looked at the review, how a problem such as this should be solved. Again, you may get credit if it is correct, but if something goes wrong, if I can't figure out what your work was, and here's systematically working, so you see I'm enumerating the binary number expansion for the first 8 numbers. So you can read these first 3 columns as the first 3 numbers, then you have the negations, then you have the ands. So I started out with the second expression, which was a little bit shorter, which was not that intimidating at first, but you can see there is the similar complexity. Also here, transforming to the raw format, you see the markdown table. So very simply typeset. So if you use this markdown table in this manner, and there will be other questions that come in a markdown table, then you actually show that you have looked at the review, that you have used markdown. Also later courses, and the Jupyter notebook is also used frequently in data science. So Jupyter and in general notebooks are very useful to document your work. All right, the first two questions are therefore solved. So here you see now the circuit. I have displayed the circuit here as a picture file inside the Jupyter notebook. You could here now also look into the PDF file of the slides. So this is to make things self-contained. So there are two questions. What does this circuit compute for 0, 1, 0? But you could also immediately solve the logical expression, as I will do next, and then evaluate that logical expression. So we recognize that there are three gates here. So they take inputs A, B, B, C, C, A. So you can, in your answer, also structure your answer. You must recognize that this is an AND gate. These are the OR gates. And there are some orders to it here. So with the brackets, you can really indicate the order of operation. So this is done here in the answer. So the circuit is actually you should be able to read this quite directly. I'm pointing out at the brackets here. So there are the double brackets. So that means that the output of the first OR becomes the output of the last, becomes the input of the last OR. So in some sense, this is what you indicate here with this logical expression. And then the answer is just 0. When this was simply a paper and pencil, the answer then was to put a 1 here. Perhaps you could still do this on the slide. I can actually mark this up. There might still be a way to also show your work in that way. So you could put a 0 here, a 1 where we have the B, then this will be a 0, here will be a 0, here will be a 0 here. So marking on the diagram could be simple enough, but there should be then also a picture taken. Okay. Now, so we are halfway the review. I'm just scrolling through the answers here, giving the impression that you can solve these questions in just a minute or two. This is not true. So I spent quite some time formatting the questions and formatting the answers. So I don't want to go through this again. I may show some of the flow charts. Again, I will show you the flow chart. Perhaps I will not show immediately the picture. But I can motivate what is the main point of this question. So this is a for loop. It's a loop, and with a loop, loops are very useful with flowcharts. But with loops, you also always have initializations. There are two explicit initializations here. So we have an N, an S, and then we have a K. So these are the three actors in this algorithmic design. You must initialize the K before the loop. So a for loop is very convenient because it kind of takes care of the initialization in the statement of the loop itself. Also, the increment is important. So here is the algorithm. I took a screenshot in this, and so just was in case when I got into time pressures. Also, it's kind of tedious to watch me struggle with this, but the diagram is important. So in your launcher, you have a diagram. And I prepared this. So this is my sketch. This is my sketch as is this displayed here. It's certainly not perfect, and you can do this in many ways. So you can start with this diamond, which is the test. Every test has a true and a false, or a false and a true. Whatever you label, it may depend on the algorithm. You have what is important for the for loop. You have this initialization and you have the decrement. So drawing this could be a little tedious, but as you struggle with this, and I wasn't struggling that much again because this is already, I have already during the semester made a lot of drawings. I hope that in preparation of the final exam you would make at least one drawing. Um, Okay, and also in Jupyter, in the Gradescope, you can upload this. Also, that's also possible. Okay, let me emphasize again what is the uh, purpose of this exercise. So we can reason on this loop. So I can show both the code and the picture here on this environment. So you have the initialization of the loop counter, starts at n minus 2. It goes all the way to 0. So it should actually go to 0 when it is negative, and you can kind of see negative will be bad because I will wrap around in Python or will go out of bounds in other languages. So I start to decrement here and before I do the next computation. So thinking about computations, so this is a computation with one single loop. On the exam you may have a double loop, a triple loop. That's an indication. So inside the loop there could be a test so that even if there is a double loop, it may not always mean that there is a square complexity, but it's a strong indication. So here we have a single loop and we don't return. So you could have actually a double loop that always resets after one. So that also actually goes through sequence multiple times. You have to be careful of this. Um, but we run through this loop n minus times. So this is a linear, we say that the algorithm has a cost linear in the dimension. If you are wondering what this algorithm now really does, so this could be another point. Describe in words what this algorithm does. What is the meaning of this algorithm? This is not the input-output specification. So the input-output specification says what is list, what is the sum. So what you should recognize that this is actually a polynomial here. So it's the sum of all the coefficients multiplied with the corresponding power. So what this algorithm does, if you need to give a good name for this algorithm, it is the polynomial evaluation. So that's also a possible question that you could get, that you could summarize, given an input-output description, that you can summarize what it does. I could also ask you, actually, given a summary, given a polynomial evaluation, what are the inputs? List all the input, list their types. So here the type is a list. Then also describe what is the output. We've seen actually very specific ways to do this with the preconditions and the postconditions. And also you could be asked what is the loop invariant on this. So the loop invariant is here that the counter k is still 0 or positive and is not greater than n minus 2 for as long as this loop runs. And the sum is also the partial sum here of this polynomial evaluation. All right, 10 minutes left. So I could have scrolled very quickly through this. Perhaps I will do this now a little bit, 5 minutes for each question. And here it's again pretty bad that I have scrolled through. So in some sense, the benefit of the Jupyter Notebook is that it allows me to view both questions and answers, which is not too good, not too bad. But here also to indicate that in order to come up with the correct example, I do not expect to see that much text. So one phrase, one sentence for every principle is good, although you could, for the high cohesion and low coupling, you could break it up in two parts. So why is this design, the first design, so much better than the second? Well, if you are designing Calculus 1, should you know about Calculus 2? Perhaps you should actually. But so these questions and answers are meant to prepare, are meant to access whether specific knowledge on Calculus 1 is tested. With questions and answers in separate modules, you could say there is information hiding. So we had a quiz earlier, so we had the design of an automated quiz, and they're actually separating questions and answers is good. So in some sense, if you will get full credit if you say that, look, questions and answers must be separate, because you, if there is ever a break-in, if there is ever a security issue with the questions, no problems. Most exams, if students would see the questions, it would still not really helpful. It's the answer key that must be carefully hidden away. The answer key, so you could say information hiding, questions and answers should be separate. Here, if you design Calculus 2, you shouldn't really be worried about the specific knowledge about Calculus 1. So, and that also refers to the low coupling. So with the questions and answers, you will have a very high coupling. So if you, in the, so the reason for doing modular design is to get to larger programs which are developed by teams of programmers. In the second part here, high cohesion and low coupling, you actually like that there is a separation, that two people can work independently on this. And that can be done with the high cohesion and the low coupling. So in the first design, there's actually no coupling between the two modules. You could, in your justification, as I did here, always refer to the other design. The other design is not good because there is such a tight coupling between the two modules. So also, if you add one question, if it's on Calculus 1, Calculus 2 is not affected, but in the questions and answers, both modules are affected. So this is kind of a very straightforward answers, but you would get very close to, if this would be on 20 points, missing the one or the two will give you 2 points. So if you get the correct answer, but no mentioning of the good principles of modular design, then that will only give you 2 out of 20. If you give code instead of any answer, like some people did on the quiz, then you will get 0, a flat out 0. And this is pretty bad because given that this is such an important topic, we spent one entire week in this course. I'm sorry, half a week on this course on modular design, 1 week in a regular semester. So it's quite important. Object-oriented design, so you must know the difference between class diagrams and use case diagrams. This is still a relatively vague question. So in a large application, you will have many classes. You will have multiple use case diagrams. We didn't really do an extensive elaborate UML design in this course. What is important is that though that you make the distinction, that you can make the distinction between a class diagram and a use case diagram. On this review here, I ask both. And it would be preferable so that you would answer this with the diagram. I know that if you have never done this, so here you see the class diagram. It's very basic. So you can see, let me break this open. So there is this UML here. So there are several items you can look for. If you do this the very first time, it is frustrating, and it's certainly so that you have to spend 5 or 10 minutes on each question. So I'm scrolling through this, doing this in 4 minutes. It is a review, but the most important thing here is that you understand the questions. So here I'm bringing up the questions again. Also describe. So there is a markdown cell. So there is the picture, but then for every attribute, so in a class diagram, you have the name of the class, car. You have the two data attributes here. Here, two data attributes. In an application, there would be many more, but here it's mainly the sake that you can say what are the key attributes, what are the key methods. So in a diagram, you abbreviate. In the explanation that follows, you are having at least one phrase for what every method does. In the lectures, I have given examples how you could solve this in a plain markdown with the triple quotes. This has a little bit the advantage that you could use these ASCII, uh, very similar to a markdown table, and you could have the phrase written next to the picture. That's perfectly fine as well, if that works better for you. In the use case diagram, you only list the methods. It's not strictly wrong if you also list the data attributes, but you are then mostly concerned with what the actors can do. So you cite the name of the class. So this is the big app, the big application. So it's pictured here. You can draw stick figures. You won't get extra credit for drawing smiley faces on them, but if you have plenty of time, you could do so. You must also provide a description. So what do these stick figures, these actors mean? So we have an employee, we have a customer. So you see, there could already be one extra class. There should already be one extra class for a person, and we have seen the library application for modular design, the same than the object-oriented design. So you must also describe, so you have already good names for the two actors, so you should describe what these type of users are. And what are the operations that both can do? So this is indicated here with the arrows. So customers can do these first four operations, and the employees can, in addition, change the status of the cars. They can add cars and delete cars. Customers are not supposed to do this. Okay, I hope that this helps in preparation of the final exam. At the very least, in order to be successful at the final exam, look at this notebook here. So you may get a good idea of what is expected of you.